Hey, party people. Okay, you know how this works. We learn about one thing and we move on because math is very sequential. So, today, after learning about slope, we're going to show you guys how to graph lines in a form that's referred to as slope intercept form. There's actually three forms of a line. Slope intercept form is probably the most common and most used. Anytime it's in that notation right there, we can always just graph it quickly on a graph given the b value and the m value. And there's two other forms. We will talk about that at a later date. One of them is called standard form. The other one is called point slope form. So here we go. This is what slope intercept form looks like. If you guys want to take notes on this one, y equals mx plus b. So y is all by itself. You have the mx plus b, and you just interpret what those values mean whenever it looks like that. The b value represents the y-intercept, or where it crosses the y-axis. And the slope is the m. That's the coefficient in front of the x term. So that is what slope-intercept form is. You guys can see that down here we have three of these initially are in slope-intercept form. If you look at this one right here, the b value is 3, so that's where it's going to cross the y-axis, and the slope is 2. Same thing for all these here. You just identify the b value, the m value, and very similar to the pre-skills warm-up we just did. All you got to do is figure out where the point is on the y-axis and then draw your slope through that based on prerequisite skills from the last section. This one over here is what I was referring to a second ago. Initially, this is not equal to slope-intercept form, but we can always convert it into slope-intercept form. So this is what it looks like. So this is called standard form. That's our next section that we'll cover. This is slope-intercept form. All right, so very similar. Whether you guys know it or not, the warm-up that we just did about 5 minutes ago, if you did that, then this is the exact same idea by design. So you guys have y equals 2x plus 3. That is in slope-intercept form, where b is the y-intercept and m is the slope. So that means 3 is where we start. That's our first point. That's on the y-axis right there. So you plot that point. And then we take a slope of 2. We know what 2 means. A slope of 2 means from previous section. It means the rise over run. You go up 2 and over 1 to the right, like so, and you put a new dot. And from that point, you go up 2 and over 1 because the rate of change is always constant. That's what makes it a line. So that's 2 points to the right. That would be enough. Really, all you need is 2 points and a ruler, and you guys can do that. That's what the rule says, 2 points to determine a line. But for this class, we're going to need a total of 5 points because we want to demonstrate our knowledge of slope, just like we did last section. So from the y-intercept, what you want to do is go back there. That's the starting point, and we know that when you go to the other direction, to the left there, instead of going up 2 and over 1, you're going to go down 2 and 1 to the left. And you're going to repeat that process right there. And when it's all said and done, now you have 5 points. And the last thing we have to do is just draw or sketch a line through those 5 points. You want to extend that line as far as it goes because that's what lines do. If you only made it as far as the 5 points, that would be a line segment. And make it go as far as your graph goes and put arrows on the end to show that it goes on forever. So please make note of those 3 things that you guys need to receive full credit. All right, we can always check our answers here. If the answer key is not available, you guys can always get on Desmos and use that as the resource that it is and check it out to see if your line matches up. Make sure it's going the right direction, make sure the slope is the same, make sure the y-intercept is the same. Next problem, very similar but different. This time the y-intercept says plus 4, that's the b value, so we're going to put a dot on positive 4. Got a little ahead of myself with that push right there, but we know that the slope is negative 3 at this point, so we know that that goes down 3 and 1 to the left. And then from that point, down 3 and 1 to the left, so I did both points. Instead of individually, they both appeared together. And then you go back to the original starting point at 4, and you go up 3 and 1 to the left, and up 3 and 1 to the left. Should continue to be a straight line like it always is. You're going to extend the line as far as it goes, and you're going to put arrows on the end. We all know that negative slopes go down to the right, they decrease, so that should be no surprise to us on that one. Again, you can check Desmos if the key is not available. All right, this one, a little bit different. You guys know how this works. We just take little steps in different directions here, but the process is the same. A minus 5 indicates that the y-intercept is at negative 5. The slope on this one is 1/4. So we should be, from that point, we should be going up 1 and 4 to the right, up 1 and 4 to the right. And go back to the starting point at negative 5 on the y-axis. And we're going to go down 1 and 4 to the left, down 1 and 4 to the left. So last thing we gotta do is draw a line through that, put arrows on the end to show that it goes on forever, and that's how that works. Pretty easy once you guys get the hang of it. You're just taking your knowledge of slope and you're given a starting point and running with it. All right, next one here. This one is going to be going down to the right because it's decreasing. It's a negative slope. It's going to start at +1 on the y-axis, and we know that a slope of -5/2 means down 5 and over 2 to the right, and then again down 5 and over 2 to the right. Go back to the starting point at 1. Or you can go up 5 and 2 to the left, like so. Up 5 and 2 to the left. Now you'll notice if you go up 5 and 2 to the left on this one, on this graph, we actually go off the graph. So you're not responsible for that point if anything goes off. Normally 5 points are required, but in this case, if it goes off, don't worry about it. Still have enough points to figure out that the line is going to be going down to the right, and like that, arrows on the end. All right, this one here, this is not initially in slope-intercept form. Slope-intercept form is y equals mx plus b. This one's a little bit different because x and y are on the same side. So we can convert it, no problem. You can always convert it back and forth any way you guys want to. It's always best to graph these using slope-intercept form. So we're going to convert this into that form now by taking the original equation where x and y are on the same side, and we're going to move the x to the other side. Now, it's important that we don't put y equals 4 minus x because that's not in slope-intercept form. Slope-intercept form is specifically y equals mx plus b. So now that's in slope-intercept form. Now we can graph it just like we did a second ago. Crosses at 4. Slope is -1. That means down 1, 1 to the right. Do that twice. Go back to 4. Go up 1, 1 to the left to complete the line right there. Always makes a straight line because x to the first power. Line through it all the way as far as it goes. Arrows on the end, and we're good on that one. All right, another little baby step here. Math is very sequential. We're going to do the same exact thing. We're just going to solve for y, but this time we have coefficients. So we start with this. We're going to move the x to the other side. I want to get it in the proper format there, so it looks like that if we subtract 4x from both sides. Now I want to get y by itself, so we're going to divide both sides by -2. And when you divide everything by -2, you're going to individually divide those by -2, and it ends up looking like this. Now that's in slope-intercept form where the y-intercept is at -4 and the slope is 2. So that's just what we've been doing there. You got 5 points. Extend that line, arrows on the ends, and call it a day. Now, if you were to check this in Desmos, the question is, which equation do I plug in? And the answer is, well, either. I mean, they should be exactly the same. If you solved or converted correctly and didn't make any calculation errors, if you were to graph both of those on Desmos, they would land right on top of each other because they're the same. They're just in different forms. All right, and last but not least, we have this one here. This one looks a little weird, but we know from last section that y equals, those are always going to be horizontal lines, whereas x equals are always going to be vertical lines. Now, let's take a look in terms of slope-intercept form right here. You really don't have to use slope-intercept form. You just got to identify this as horizontal line. But if you want to think about it in terms of slope-intercept form, it looks like this, where the slope is 0. We know that the slope of a horizontal line is 0. That's why the x goes away. And all you're left with is y equals 3. So on this one here, you just start at 3. You don't really need 5 points. You just need to draw a horizontal line through that, looking like so. Now, I'm not going to give you a x equals yet because I'm going to show you that in another section. Or I showed you that last section. We'll revisit that one again. But x equals would be a vertical line. That's the only one that you can't write in slope-intercept form because there is no y equals value. So keep that in mind that x equals are vertical lines and the slope is undefined, whereas horizontal lines look like this and the slope is 0. Those can be written in slope-intercept form. All right, thanks for listening. You guys have an assignment that you're going to practice independently now. And if you have any questions, let me know. Otherwise, talk to you later. Bye-bye.